Okay, accelerated study. Let's solve some systems of inequalities. And we do this by graphing. So we just graph the inequalities as we have always done. And that's my cat. Let's start with y is less than or equal to 3. We'll map out 1, 2, 3, right? And put a lovely line there. What is happening? It's a solid line, of course, because 3 is actually included in the solution set. So let's shade underneath. No, we don't want that. We want this. Do. Some lovely shading. Okay, then we map our graph y is greater than x. We remember this, and we don't have a nice dotted line option on my little shapes menu there, so I gotta hand draw it. So this is gonna get ugly, right? We are familiar with Miss Polson's work. Do. There we go. A lovely dotted line. Actually, it's some pretty good work for me. And in this case, we're going to shade, of course, above because the graph is y greater than x. So we shade. And we can see right now we have some area of overlap. But we have a third inequality to graph. X is greater than or equal to -2. All right, let's find x is -2 right there. And we have, again, a solid line. What? Go away. Honestly. There we go. We have a solid line. Oh, okay. Starting to get ticked off. All right. What am I doing? Please tell me that's -2. Okay, that looks -2-ish. Solid line. And once again, we have to shade. In this case, all things greater than -2. And what color haven't we used? Let's use gray, actually. Show. And we can see that our solution set is somewhere in here, right? We've got quite a bit of overlap there. So we'll pick a point from there, a test point. We always use test points when we're solving systems of inequalities because especially when we have to divide by negative and flip the sign, it can get pretty confusing as to where you're shading. If there's a steep slope, it can get pretty confusing as to where there's shading, where you should be shading. So we pick a test point once we have done our graph, and we make sure that it actually works for all of the equations or inequalities. I'm going to pick, let's see, -1, let's say -1, 1, right? And let's see what happens when we substitute. So if I'm using -1, 1, here I'm going to substitute 1 for y. Is that less than or equal to 3? Well, yes, it is. Here I'm going to substitute 1 for y and -1 for x, and y, 1 is definitely greater than -x, and here we have -1 greater than or equal to -2, and -1 is in fact greater than -2. Okay, so